CompTIA Cloud Plus, Cloud Native Design. Let's begin this lesson on Cloud Native Design talking about microservices. Microservices are a foundational element of Cloud Native Design. They enable applications to be built as a collection of small, independent services that each perform a specific business function. These services are loosely coupled, meaning they operate autonomously and communicate with each other through well-defined application programming interfaces, APIs, like RESTful APIs or gRPC from Google. I want to use an example here for those of you who aren't programmers or developers or coders, and I'm certainly not, to compare containers to microservices. They do have a lot in common. There was a Venn diagram. There would be some overlap between the functionality. But let's say we're going to go to the Starbucks at the airport, right? So I walk in and I'm going to go up there to the clerk on the left. The clerk is a container made up of modular microservices. So for example, they might ask me what I want to order, and I'll say, give me a grande iced, and as soon as I say that, that's going to trigger a microservice that's going to grab a clear plastic cup. The elements of my drink order, that'll be microservices. The payment processing, those are all microservices. Now, is the clerk container going to make my drink? Or for that matter, if I order some food, are they going to put the sandwich in the oven or the microwave? No, they're not. The clerk's going to make API calls to the barista and to the foodie up there in the upper right-hand corner. Now, the barista is also a container made up of lots of different microservices, such as grab the soy milk, grab the almond milk, grab the half and half. Is the barista going to make the food? Prepare the sandwich or whatever? Nope. That's going to be an API call made to the foodie. In fact, there's a delivery container that's the one that yells out my name, Mike, or puts my name up on a board. There's also a manager container that's managing this Starbucks at the airport. Now, what if I decide to upgrade the espresso machine that the barista is using? It's not going to affect any of the other containers, but it'll have some new microservices with new functionality, and it'll expose new API calls to the new barista container. Now, other things are going on here too, like cloud notification services, like Amazon SNS. So application-to-application notifications being sent from the clerk to the barista, from the clerk to the foodie, and the foodie to the delivery container. Application to person would be from the clerk container to the manager being like a programmer or a developer. So containers are more about the packaging of the functionality, for example, all the functionality of the barista, where the microservices are the actual underlying reusable and modular functionality. Containers are often packaged with Docker, and then the long-term orchestration is done with something like Kubernetes or K8. So each microservice in a cloud-native architecture is typically packaged with its own runtime, dependencies, and data storage. And that's not unlike a container either, making it technology agnostic. This means different services can be written in different programming languages or use different data stores, depending upon what best suits their function. Because of this independence, microservices can be updated or replaced without impacting the rest of the application, reducing downtime and accelerating development cycles. And again, communication between microservices is often handled through asynchronous messaging or RESTful APIs. Another term on the exam is fan-out. According to CompTIA, fan-out is a key cloud-native design concept that enhances scalability and responsiveness by enabling parallel processing. In a fan-out pattern, a single request or event is distributed to multiple independent services. So for example, you could have a fan-out within the barista container, or you could fan out from the clerk container to other containers. And they're also distributed to components that can process tasks concurrently. This approach is especially useful in event-driven architectures. In fact, I've made videos in this Cloud Plus series specifically about event-driven architectures. If you haven't seen them, go check them out. If you had, then you know what I'm talking about here. It's useful where one trigger, such as a user action or a system event, needs to initiate several downstream processes simultaneously. In fact, Fanout supports asynchronous processing, which means each task can be handled independently without waiting for others to complete. This reduces latency and improves the overall responsiveness of the system. For example, when a user uploads a photo, Fanout might simultaneously trigger services to generate thumbnails, scan for inappropriate content, and update metadata, all in parallel. Our final concept in cloud-native design is service discovery, which according to CompTIA has four main elements. First, identification of services. This involves dynamically recognizing available services within the cloud environment, and as services are frequently deployed, scaled, or removed, the system must be able to detect these changes in real time. Location of services. Once identified, services must be locatable. Yeah, that's a word, locatable. It's typically handled through service registries or DNS-based mechanisms that map service names to their current network locations, for example, IP addresses and ports. Facilitating communication. Service discovery enables seamless communication between services by abstracting the underlying infrastructure. This allows services to interact without hard-coded endpoints, supporting loose coupling, scalability, and even serverless environments. And then, automation and scalability support. Service discovery, as it relates to cloud-native design, can automatically update and adapt as services scale in or scale out. This ensures that communication remains consistent and reliable, even in highly dynamic environments. I hope this video on cloud-native design was informative for you. I want to thank you for viewing. See you next time.